Okay. Hello, students. Okay, let's look at Physics 102, Coulomb's law. Coulomb's law. This is not a new topic for most of you. I know you must have been taught this in secondary school, right? Who can tell me what's Coulomb's law? Any idea? Yes. If you can state, fine. If you can talk on it, it's fine.
Coulomb's law states that the force between two charges is directly proportional to the product of the charges. Proportional to the distance apart.
It's left for her. That is correct. 100% what? Correct. Okay. Coulomb's law. There's a man called Charles Coulomb. Charles Coulomb establishes the relationship between what? Between charges and what? And force. Now we have what called the like charges and the what unlike what charges. Either we are told that like charges does what? Repair. What about unlike charges? They attract. Are you following me now? Now the distance between the two charges determine the strength of what? Of the field and also of the what? Of the force experience. Like for instance, let's say if I have a charge here, a positive charge, and I have what here? A negative charge. Are you following me? The force experience is called a force of what? Of attraction, because we have two unlike what? Charges. Now there is the distance apart between these two charges. The more we extend their distance, the lesser the what? The force of what? Attraction. Don't be aware. It's like saying when you have two magnets, we have North Pole and what? And South Pole. You know what happens when you bring them together? That we attract. Are you there? But that attraction reduces when the distance is what? Is far. Are you following me now? So Coulomb's law gave us two fundamental laws. Like she stated, she combined all the laws together. We have two laws in Coulomb's. The first law is the force, is the law between the force and the what? And the two charges. Number two is what? Between the force and what? The distance what? Apart. Between the two what? Charges. Are you following me now? The first Coulomb's law says that the force of attraction or repulsion between the 2 point charges is directly proportional to the product of the two charges. So if I have 2 point charges here, I hope you are aware that there's what we call field. If I have a single charge, we have the lesser what? Field. If I should increase the charges, let's say plus, one to the field, it will increase. The more the charges is being increased, the more the what? The field. And this field represents the strengths of what? Of the charge. Are you there? This is what we call the field what? Intensity. The field what? Intensity. Am I communicating? Now, if I have another charge here, okay, that has its own field as well. What Coulomb is saying is that the more we increase the charge, are you following me? The more the what? The force of attraction or repulsion. Because this particular charge is creating its own what? His own field around what? This charge. Around itself, thank you. This other one is also what? Creating what? His own what? Field. So for this force to increase, we have to increase what? The what? The size of what? Of the two charges. Am I communicating?
Yes.
Are you there? So increase in the what? In the charge. This is what? Increase in what? In the force. This is the first law of Coulomb. Is it making sense? Good. So we call this what? Equation what? 1. From here I can generate a formula that says, by the time we take off this sign, what do we do? Introduce a constant, right? And what? Equal sign. So my F equals what? Somebody? K, Q1 what? Q2. Are you there? So from here we can say that the value of K is what? Somebody? F over what? Q1 what? Q2. Second what? Law. says what? The force what is inverse relationship? Inverse means what? As one factor is what? Increasing, is decreasing. That means that the more we increase the distance, the lesser the what? The force. Is it not true? Is it not? Is it not? So the more the two charges are widely separated, the lesser the what? The force of attraction experienced between them. Am I making sense? So that means what? My F is equal to what? Give me the value K over what? R square. Can we say that? Can we multiply this? K becomes what? What is that K? F what? R square. That implies what? F1 R1 square, abi, is equal to what? Somebody? F2 R2 square. Put this down. Put this down. Then let's look at the general law for Coulomb. The general law for Coulomb. The combination of the first and second law gives the general Coulomb's law. The combination of the first and second law gives what? The general Coulomb's what? Law. Are you following me? The general Coulomb's law they have a common factor, which is what? Force. So I'll pick the common factor force proportional to what? Q1 what? Q2 over what? Somebody? R square. To take off this sign, what do we have? We have to introduce a constant, right? K, which is force equals what? K Q1 Q2 over what? R square. Now the value of K is giving us what? Who can tell me? K has a value, right? 9.10 times 10 per what? 9. Newton square per Coulomb square, right? I think also per meter square, or meter square rather. So, but the value of K is equals to 1 over what? 4 pi permittivity of what? Free space. Are you aware? And the whole of this is equals to what? 9.0 times 10 per what? 9. Newton square per what? Coulomb square meter square. Yes, I think so. 1 over 4 pi. 4 pi times this is called permittivity. Permittivity of what? Of free what? Free space. Permittivity of free space. Permittivity of free space is like an open space. Every substance have their permittivity. We have permittivity of air, permittivity of paper, permittivity of wood. It's like saying a dielectric substance. You know, air is also what? A dielectric substance. Like if I have two capacitors separated by a distance, there is a permittivity, the tendency of this material to conduct what? Electricity. That means the permittivity of that free space between the two what? Charges. Are you there now? That means the space between the two charges that gives them the tendency to what? To experience the force of what? Attraction or what? Or repulsion. This permittivity of free space even has a value, I think about something like 8 point something, 8.5. Is it also? So there's always a value. The permittivity of free space between these two charges and this and that. Okay, another. Maybe in the next part I will explain better on what permittivity of free space is all about. Are you there?
Yeah.
Okay. Now, let's solve some problem. Look at this. Put this down of you. A force of 100 Newton acts between 2 point charges separated by a distance of 2 millimeter. What is our force? 100 Newton, right? What's our distance? 2 millimeter, right? Okay. Calculate the value of the force when the distance is increased to 3.6 millimeter in the same direction. 3.6 millimeter. We are told in the same direction. We are told that this distance gives a force of 100 Newton, right? Then also, what is the force when the distance is what? Increased to what? 3.6 millimeter. So this is our first distance, Abi. This is what? Our second what? Distance. Then I'm looking for what? Our F2. Is it not? I'm looking for F2. Milli means what? 10 raised power what? Minus 3. So this is the same as what? 2 times 10 raised power what? Minus 3 meter. What about this? 3.6 times 10 raised power what? Minus 3 meter. Are you aware? You convert your measurements to what? To meter. So we say recall that force is proportional to what? 1 over what? R square. Are you aware? Do you know why I'm using this formula? Because we are the question center on what? On force and what? And distance, not on the charge. Are you there? Am I communicating? So that means what? Our force is equals to what? K over what? R square. So what my K? F what? R square, right? Therefore, we can say that our F1 R1 square equals what? F2 R2 what? R2 square. Are you there? Our aim is to find what? F2. Therefore, what is our F2? We make F2 as well subject, right? And that becomes what? F1 R1 square over what? R2 square. And this will give us what was our F1? 100 times what's our R1? 2 times 3 raised power what? Minus 3. What's our R square?
3.6.
All square, right? Are you aware it's all squared? What's the R2?
3.6.
3.6 times 3 raised power what? Minus 3, all what? All squared. Can we solve for that? What do we have there? We have 100 times what? 2 squares what? 4, Abi? 4 times 3 raised power what? Minus 6, right? Over what? 3.6 square is what? What 3.6 square? 12 points what? Times 3 raised power what? Minus 6. Can these two cancel themselves?
Yes.
What is 100 times 4? Over what? 12.96. Therefore, what is our force? What? 30 point what? 8 what? 6 Newton. Oh yeah, put this down. Now what's the question again?
Can we just say recall after putting F to find 1 R square?
Okay, we call this direct. Perfect. I'm just teaching I have to show it because I'm teaching. You can just start from here. We call that F1 R1 square equals what? F2 R2 square. Then you solve for F2. Sharp. We are done. I'm not sure you understand what I just did here. Now, are you following? Sure. Are you following? One day. Are you following? Huh? Oh, yeah. Are you following? I'm not going to enter direction of action. Now, are you following? Are you following? Who is not following? Let me see your hand up. I don't understand this. Let me see your hand up. Don't start your semester with keeping quiet. Okay? But in the exam, what they say, state Coulomb's law. State the general what? Law. Are you following me? Are you there? In the exam, don't start stating the first and second. I said they say state Coulomb's law in relation to force and what? Charge. Are you there? They cannot state the first law. When I say in relation to force and distance, but when I say state Coulomb's law, state the general law. Is it okay that way? Number 2 example. Okay. Read the question from the 1 to go. Read for me.
A force of 2.1 times 10
2 point what?
2.1 times 10 raised to power
3 Newton.
Act on 2-point charges.
Act on 2-point charges. Who are those reading? 1 to go.
A force of 2.1 times 10 raised to power 3 Newton. Act on 2-point charges.
Okay.
and 8 microcoulomb.
The 2-point charges. What's the first one?
2 microcoulomb.
2 microcoulomb.
And 8 microcoulomb.
What's our second charge? 8 what? Microcoulomb.
Separated by 2 millimeter apart.
The distance apart is what? 2 millimeter.
Calculate the value of the force acting on 2 other charges.
So this is my F1, right? We are looking for what? F2. Acting on what? 2 other charges.
Yes.
Which are what?
7 microcoulomb.
Okay, now look at this now. For this force here, these are the charge, Abi.
Yeah.
Distance is what? Is this. Let's call this other force what? Let's call it what? F2. Let's call here QA and what? QB for F1, right? Are you following me? Then for F2, let's call this what? What if our Q what? QC. Our QC 5 microcoulomb. And what? What's our QD?
7 microcoulomb.
7 what? Microcoulomb. Are you following me?
Yeah.
Okay, which formula will I use to solve this? We are told that they are kept in the same medium and they have the same what? Distance. Abi? Are you there? Now look at this now. General law says what? F. Watch. Recall. The general law says what? F is proportional to what? K, Q1, Abi? Q2 over what? Over R squared. Are you there? Now let me show you something. Let me tell you something. I must not use this general law to solve. We are already told that both of them have the same what? Distance. And they are kept in the same what? Medium. Are you following me now? So I can as well use second law of what? Of Coulomb's law to solve. The law that says what? F is what? Proportional to what? K what? Q1, Q2, Abi? Sorry? Proportional to what? Q1 what? Q2. Since we are told that they have the same distance, just remove your distance from the formula. Is it making sense now? So here we have. We are told that they have the same distance. If I'm to bring out their relationship, their distance will cancel themselves. Is it not so? Is it not? You cancel off now. So just do away with this. I can as well use this to solve. Here we have F equals what? K, Q1, Q2 over what? R squared. How do we get our K? Let's make K a subject first. K is equals to what? F times this K, Q1, Abi? K, Q1, Q what? Q2 is equals to what?
F R squared.
F what? R squared, Abi? Then what's our K?
F R
F what? R squared over what?
Q1.
Q1 what? Q2. So this can as well be what? K equals what? For my FE, for this force here. So if my F1 rather, are you following me? F1 R what? R1 square, right? Over what's the force for this F1? What the charge for this F1 rather? QA and what? QB. Is it also? So what will be here? QA, Q what? QB. What will be here? Equals to what? F2, Abi? R what? R2 what squared. Over what? Q what? C, Q what? D. Are you there? Since they say that their distance are what? The same. That means this we cancel this from here. Is it not it? Is it not what I said? Is that what I said in the equation? They will cancel off now. If your R1 equals R2, that means they are the same. They will cancel off from the equation. Then when they cancel off, what's our K? K becomes what? F1 over what? QA, QB, right? Equals to what? F2 over what? QC, QD. That's why I said I can just use this direct. F and what? This. Just neglect this. It's more simpler that way than going through this process. Let me use that one, Abi. Do you want this one? It's long. Good. So since they say they have the same distance, I've proven that the distance will cancel out. Abi? So since they will cancel out, let me just use this direct to solve. From this other law, we agree that we are aware. Just recall that K. What's the value of K for the second law? Give me the value of K. F what? F R square. For the second law, not this thing. So the first law. Huh? F over what? Q1 what? Q2. Hope you all know how we got this, right? This K is not the same thing with this. It's the same thing, right? So I can solve direct from here, right? I can say that this is same as what? Therefore, we have for my F1, what's that charge? Is QA, Q what? QB. Abi? Is equals to what? What's that F2? What's that charge there? QC, Q what? QD. Which is better? This, Abi? So can we now solve for the F2? That means that anywhere we see F1, we put this, Abi. We have F1, we have charge A, we have what? Charge B, Abi? We are looking for what? F2. We have charge C, we have charge D. It's not simple now. It's simple, right? Okay. So let's proceed. F1, give me the value. 2.1 times 10 power what? 3. Divided by what? What's our Q1? Our QA? 2. Now let me tell you something. Since I have how many charge here? All of them, all the charges have the same units now. I can just neglect this micro. Even though I put micro here, they will still cancel out from here. They will cancel out now. I'm making your calculation easy now. Although I can put 2 times 10 minus 6 times what again? What's that QB? 8, Abi? But there's an equal sign here. This will cancel this. Or let me put it and see. Watch. What's that QA? 2 micro, Abi? Times what? What's that QB? 8 what? Micro. Equals to what? What's our F2? Unknown, Abi? Over what? What's our QC? 5, Abi? Micro times what? 7 what? Micro. Can micro cancel micro from here? Can this cancel this from here? Do you get the concept now? So 2.1 times 10 power what? 3. Divided by what? What's 2 times 8? 16. All equals to what? F2 over what? What's 35? So how do we get our F2? We cross multiply, Abi? We cross what? Multiply. And that will give us what? F2 times 16 is what? 16 what? F2 equals what? 35 times 2.1 is what? 73.5 times 10 power what? 3. So how do we get our F2? Divide both sides by 16. So that means my F2 becomes 73.5 times 10 power what? 3 divided by what? 16. What's our F2 when divide? 4 point what? 59 times 10 power what? 3 Newton. Or 4.6 times 10 power what? 3 Newton. You can check here. When you get back to your house, make sure you master this. The other aspect of Coulomb's law. Let's look at the other aspect. We have what called direction of action and direction of force. Are you following me? Sometimes you will need to employ what we call vectors to solve Coulomb's law. Now that we all know what is vector, right? What's vector? What's a vector? That has what? And has what? Direction. Are you following me? They have size and what? Direction. So that means if I have a charge, I have another charge here, and the distance of separation between these two charges separated by what? By R. Are you there? Let's say I have another charge here. Charge what? Charge 3. If the distance between charge 1 and charge 2 is A, for instance, charge 2 and charge 3 is what? Is B. Now you might be asked to use Coulomb's law, or Coulomb's force law rather, to find the force acting on what? On either charge 3, charge 2, or what? Charge 1. Are you following me? There's no way you can use your normal F equals what? K, Q1, Q what? Q2 over what? R square to solve this. Although this is part of the formula, but it's not just the whole. It's not just everything. Are you there? Even though we have two charge, this formula is mostly used when we have what? Two charges. I mean, they'll say find the force between what? The two charges. Use the formula to solve. But when they say find the force acting on charge 1, I have to employ what? Vector. That means they are now showing you the direction where the force is acting towards. Isn't also? And whenever they now indicated direction, that means you have to employ what? Coulomb's vector. Or you have to employ direction of what? Of action, or direction of what? Of force to solve it. Either if I have two charges, charge 1 and charge 2, let's say if charge 1 is greater than what? Charge 2, the action of this force will act towards what? Charge 1. There will be a drag towards charge 1. Either that's why when you see two magnets and you are trying to bring them together, one will attract the other more than the other, because the size of charge 1, if it's more than charge 2, the force of attraction will act towards what? Charge 1. And when it comes to vectors, you have to take note that the x-axis represents what? The I component. The what? I component. Here we have a positive x, right? Here is what? Negative x. What do you have here? Positive y, negative y. So the direction of any charge in this component is what? Is I. The direction of any charge in this component is what? Minus I. Direction here is what? Is j. Here is what? Minus j. Are you following me? Now if you also find the direction of action of charge 1, the answer is what? Minus what? I. Direction of action of charge 2, what's the answer? Plus I. And if I have a charge here, I have charge 1, I have what here? Charge 2. And if you find the direction of action of charge 1, what's the answer? Plus j. That means the action is acting towards what? Y, positive what? Y-axis. Is it making sense now? So one, I'm building up the because. So the direction of force indicates what? The direction of what? Of action. Are you there? There is always a direction of force, and there's always what? A direction of what? Of action. Are you following me now? Sometimes they might even give you something of this nature. And there will be a charge here, and that charge here, and that charge here, and what? And that charge. They will tell you what is the direction of, what is the force acting on charge 1. If you don't understand what I just said now, you can't solve that problem. You don't understand this. Now listen again. I'm trying to explain what we call direction of action. There's always what? Direction of action when 2-point charges or 3-point charges are kept in a system. If I have 2-point charges, Q1 and what? Q2. These two charges lies in what axis? On the S-axis. Isn't also? Then they say, what is the direction of action of charge 1? The answer is what? Minus I. Because the direction of action on charge 1 simply means it is acting towards what? Charge 1. Is it making sense now? If they say what is the direction of action of charge 2, it means what? It means what? Positive what? Is it making sense? And the force, the direction of action on charge 1 is always represented as what? As arrow 1, 2. Arrow what? 1, 2. Meaning from 2 to what? To 1. Either. And the answer here is what? Minus I. Direction of action on charge 2 is what? Arrow what? 2, 1. Meaning what? From 1 to 2. What's the answer? Plus I. For the horizontal components. But for this vertical components, direction of action on charge 1 is what? Arrow what? Arrow what? Arrow 1, 2. Meaning from 2 to 1, which is what? J. What about that of 2, 1? minus what? J. Do you understand this now? This is the first basic you need to understand when it comes to direction of action and what? Direction of what? Of force. Are you following me? Am I communicating?
Yes.
Okay. Now put this down. Not the following. If we have this given Q1 separated by what? Q2. And the distance of separation is what? Is R. Then when or if Q1 is greater than what? Q2. That means that the direction of action will fall into what? We move from where? From Q2 to what? Q1. Is it not so? If your Q1 is more than what? Q2, the action will move towards Q1 because Q1 is what? More than. Is it not so? Direction of action, which is what? R what? R1, 2, right? The action is acting on what? On charge 1. Is it not so? Which is equals to what? What's my answer? From 2 to 1 is what? Minus what? I. Is it not? In your Cartesian diagram, I said this is what? Plus I. This is what? Minus I. This is what? Plus J. This is what? Minus J. Are you there? So we are considering what? Horizontal what? Components. Then what's our direction of force? Direction of what? Of force. Direction of force is F1, 2, which is equals to what? What's Coulomb's force law? K Q1 abi? Q what? Q2 over what? R what? Square 1, 2 multiplied by what? Unit vector of what? 1, 2, which implies what? F12 equals to what? K Q1 Q2 over what? R square 1, 2 multiplied by what? What's the direction of action? Minus I. This is my answer for this. Under option 2, if Q2 is greater than what? Q1, what do you think will be the direction of action? It says what? R2, what? 1 a day? Meaning from 2 to what? From 1 to what? To 2. And what's the answer? I. From 1 to 2, that means I'm moving from this region towards what? Positive I. This is my negative I. This is what? Positive I. Is it making sense now? Okay. What's the next one? Direction of force. Horizontal. The same thing that will what? Repeated for what? Vertical. Should we look at that one? Is it the same thing, Abi?
No.
Complete yourself now. Oh yeah, let me look. People like stressing me, Shannon. Oh yeah, let's go. But I will just pick only one of it, then I will explain. If we have this, and we have charge 1, and we have what? Charge 2, separated by distance R. And if charge 1 is greater than what? So I will just give you one, then you can use your So who can tell me what is the direction of action? Of action? Is what? Unit vector of what? Of action 1, 2?
Yes.
1, 2. Meaning from 2 to what? To 1. What's the answer? J. Abi? Okay, what is J? The Y component is what? Positive J and what? Negative what? J. What's the next one? Direction of what? Force. Are you there? Are you following me?
Yes.
So I can say similarly, right? What do you think will be our F21? What's our F21?
K,
Q1, Q2 over out good times what? Minus J, right? Hope you are aware it's minus J. For F21, that means for 1 to 2. 1 to 2 towards negative what? J. Negative Y axis and negative J. Are you there? I hope you are aware that in vector, your I represents your S axis, J represents your what? Y axis. While your K represents your what? Your Z. Are you there? Your Z component. Let me just give you. Look at this. Listen. For given Q1, Q2, and what? Q3. Separated by distance, we have A, we have what? B. Are you there? And we have to find the force. Find the force acting on Q1. The force acting on Q1, the force acting on charge 1. There's what we call superimposition of forces. Super what? Imposition of forces. Superimposition of forces. Okay? For charge 1, if we have to find the force acting on charge 1, that means that the direction of action is towards what charge? Charge 1. Meaning from what? From 2 to 1 and from 3 to what? To 1. I don't know. Emphasis is on what charge? On charge 2. So all of these two charges will move towards what? Charge 1. If you have to find the force acting on charge what? On charge 2. What happened? Becomes from 3 to what? From 1 to 2 and from 3 to what? To 2. What about on charge 3? From 1 to 3, from 2 to 3. Just that way. Well, let's look at the first one. The force acting on charge 1. Right there. The force acting on charge 1, according to superimposition of forces, is given as what? As F1. As what? F1. F1 means force acting on charge 1, which is equals to what? From 2 to 1, Abi? Which is what? F what? F1 2 plus what? F1 3. Is it making sense? So the force acting on charge 1 is the summation of what? Of all the forces acting from 2 to 1 and from 3 to what? To 1. Am I communicating? Are you following me? What if I say find the force acting on charge 2? Here becomes what? F2 equals what? F2 1 plus what? F2 3. Abi? What if they find the force acting on charge 3? What do you have? F3. Are you following me? So our F1 becomes F12 plus F13. Although we can also say F what? 1 1. Force acting on itself is what? Is 0. The whole of this is what? Is 0. So we don't put this in the expression of force of the forces. Are you there? I can say F1 equals F11, F12, F13. So any force acting on itself is what? 0. So the formula says that force acting on charge 1 on the first charge, which is F1, equals F12 plus what? F13. For F12, what do we have? We have KQ what? 1, Q2, right? Over what? R square 1, 2 dot unit vector of what? 1, 2. What's the value for this unit vector? Who can tell me? From 2 to 1. From 2 to what? To 1. Which is what? Minus I. Abi? You want to be what? minus I. The distance from 2 to 1 is what? Is A. What will be here? Here becomes what? A what? A square. 1, 3. F1 3 becomes what? For F1 3, it becomes KQ1 Q3. Abi? Over what? No. From 3 to 1, distance is what? A plus B. Also AB square. How many distance did you cover from here to here? It's 2 now. A plus what? B. Here becomes A plus B. All what? Squared. Is it making sense now? What are using vector again? Minus I, because it's still moving towards what? Towards what? Negative what? Recall that F1 is what? F1 2 plus what? F what? 1 3. Abi? That means what? F1 equals what? What's that F1 2? KQ1 Q2 over what? Over A square times what? Minus I, right? Plus, is it not plus? What's that F1 3? Q1 Q3 over what? A plus B all squared, right? Times what? Minus I. One becomes what? Here we have minus I times this is what? Minus KRB Q1 Q2 A square, right? I, right? Minus, because minus I times this will give us minus AB. We are minus K Q1 Q2 I Q3 rather K Q1 Q3 over what? A plus B all was squared. Final formula for this diagram. Let's solve one example. Watch. I have a straight line here. What the first charge? What the first charge? 88 microcoulomb, right? What is second charge? Huh? Minus what? 55 what? Microcoulomb. What the third charge? Microcoulomb. And the central one is what? 0.75 meter away. Abi? That means here should be what? 0.75 meter. Yes, what? 0.75 meter. So this is my charge 1. This is what? Charge 2. This is what? Charge 3. Then we have to find the force acting on each of them. Abi? The net force acting on what? On each of the charges. So that means I will look for the net force acting on charge 1, acting on what again? Charge 2, and also what? Charge 3. So we have 3 in one question, right there. Okay. Now for the net force acting on charge 1, that will give us what? F1. And that will give us F1 2 plus what? F1 3. Meaning, according to super what? Equation of forces, the force acting on this charge is the force acting from charge 2 to charge 1, and from charge 3 to what? To charge. Are you following me now? So from charge 3 to what? To charge 1. These two charges are acting towards what? Charge 1. So from 2 to 1, then from 3 to what? To 1. Am I communicating? That means they are all acting towards negative what? I. Because from the Cartesian diagram, here's what? Minus I, here's what? Plus I. So if I have the 3 charges lying horizontally, and charge 1 is here, I have charge 2 here, I have what? Charge 3. So all of them are acting towards negative charge, towards what? Negative what? I. Either. So for this, I'll do, let's find, the first thing to do is to find what? To find F1 to be. Our F1 2 is what? Is KQ1 Q2 over what? R square 1, 2 abi times what? Unit vector of what? 1, 2. Is this clear?
Yes.
Can I continue? Yes. For my F1 2, for this F1 2, between this charge and this charge is from here to here, right? What's that charge 1? What's our charge 2? Can we keep on solving? What's our distance apart? 0.75 meter, right? So here becomes what? Our F12 becomes, what's that K value? K is what? 9 times 10 raised by what? 9, Abi? Multiplied by what? What's that K? Our Q1? 88 times 10 raised by what? Minus 6. Is it not? Micro means what? 10 raised by minus 6. Then multiplied by what's that Q2? Minus 55 times 10 raised by what? Minus 6. All divided by the distance between charge 2 and charge 1 is what? 0.75. So 0.75 all what? All square. Multiplied by what's our unit vector from 2 to 1? Minus I, B. Why? Because the action is towards what? Negative I. Here becomes minus I. So here we have our F12 equals what? Move your point this way. 1, 2, 3. That gives us what? 77.44 I. All in what? Newton. Is it? Okay. So let's find what now? F1 what? F1 what? 3. For F1 3, what do we have? K what? Q1, Q3 over what? R square 1,3 dot unit vector of what? 1,3. So our F13 becomes what? What's our K? 9 times 10 raised by 9 times what's our Q1? Minus what's our Q1? 88, right? Times 10 raised by what? Minus 6. What's our Q3? 70 times 10 raised by what? Minus 6. All divided by I. This will give us what? F13 equals what? Minus, right? Let's move our point. How many times? 1, 2, 3. That will give us minus 24.64. Is it not? Okay. I. All in what? Newton. We call that F1 equals what? F12 plus F13. And that will give us our F1 is what? What is our F12? What is it? 4 what? I, right? Plus, what is our F13? Minus 24. Point what? 64I, right? This will give us what? F1 equals what? 77.44I minus 24.64I. What's the final answer here? Subtract both. What do you have? 50 what? 0.8 Newton. I mean 8I. 8I what? Newton. What is my force? Absolute. Well, I have to find the net force, Abi. It's not net force. How do you get the net force? Who can tell me? What's the net force? Net and put what? 52.8 what? Newton. Are you following me? Or you can say what? F1 equals what? Modulus, Abi. That will give us what? 52.8 all what? All square. Is it not so? Can square cancel square roots? What's the final answer? 52.8 Newton. Is it not? Is it not?
Yeah.
Now, force is a vector what? Quantity that has what? Magnitude and what? Direction. Don't just stop here. You have to find the word direction. What is that direction? What do we have here? Positive I, Abi?
Yeah.
Direction means what? Towards what? Towards what? Towards the positive X what? Axis or direction. Are you following me?
Yeah.
Because the value of I represents what? The S axis. So this value here, 52.8, is what? The size or the net force. Then the direction is what? I. So this I indicates that the two charges are where? On the S axis. But it is acting towards what? Positive what? S what? Direction. Is it making sense? Is it making sense? What sign do we have here? Yes, what? Plus, Abi. If I have minus sign, that means my F1, the force acting on charge 1, is acting towards negative S direction. Since we say that in the Cartesian diagram, our S represents what? The I, Abi? Yes, what? Minus I. So since we have plus I, 52.8 is the net force, is the size of the force experienced. Are you following me now? Then the direction of that force is towards what? The positive S direction. Is it clear? This word defines force as a what? A vector. Force is a what? Vector. It has what? Size and what? Direction. So for the force acting on charge 2, we said it's given us what? F2, Abi? That means the force is acting on charge 2, which is what? F21 plus F23. Our F21 is giving us what? KQ1 Q2 over what? R squared 2, 1 times unit vector of what? Unit vector of 2, 1, which means the direction of action is from what to what? From 1 to 2. That means it's moving towards positive I, right? So here becomes what? Times what? Times I. So the value of K is this. Value of Q1 is what? Is this. Value of Q2 is what? Is this. Divided by our distance between charge 2 and charge 1 is what? 0.75 all squared multiplied by what? Unit vector. And that will give us, what do we have here? Multiply the numerator for me. Multiply 9 by 88 by minus 55. What do you have? What? Our F21 becomes what? 77.44 I. Is it not? So minus, there's a minus sign here. Is it not so? All in what? Newton. Okay. Also, let's find our F23. For F23, what's F23? KQ what? 2 Abi? Q3 over what? R squared 2, what? 3. Is it making sense? Times unit vector of what? 2, 3. So F23 becomes what? What's our K value? 9 times 10 raised power 9. What's our Q2? Minus what? 55 times 10 raised power what? Minus 6. What's our Q3? What's our Q3? 70 times 10 raised power what? Minus 6. All divided by what? The distance between charge 2 and charge 3 is what? Is 0.75. 0.75 all what? Squared. What's our unit vector? Is what? Negative what? That means from 3 to what? To 2, Abi? Towards negative direction. So we have minus what? I. Okay. Therefore, our F23 becomes what? What's 9 times 55 times 70? What do you have? So our F23 becomes what? Let's move our point. 1, 2, 3. 61.6 I. All in what? Newton. Then we say recall that F2 equals what? F21 plus what? F23. So our F2, the force acting on charge 2, what's our F21? What do we have there for F21? Minus 77.44 I plus what's our F23? 61.6 I. Are they like terms? We have I, right? They can be added, right? So what's our F2? Minus 77.44 plus 61.6 is what? Minus 15.84 I Newton. Is this our final answer? No. Then we'll look for the net force, right? What's our net force? Net force is what? 15.84. What's our direction? Towards the negative what? S axis. Is it making sense now? Our net force Net force on what? On chart 2. This will give us what? F2 modulus. That will give us 15 watts. 0.84 Newton. Then the direction of this force becomes what? What's that direction? Because we have this value 15.84 is our net force. Direction is what? Minus I. So we have toward the negative S direction. Towards the negative X what? As is Abi. That is all. Then you now find what? The force acting on what? Chart 3. It's 3 in one question. Hope you are aware. Force. So those watching, you can solve for the force acting on what? On chart 3. Okay, this is your assignment. Then when you solve, please indicate your answer in the comment section. Thank you.